we are going to calculate electric field strength in some, I will not say complicated cases, these are some interesting cases. EFS, due to some interesting charge distribution. I'll just remind you one of the very interesting case which we have already done. Due to this circular charge distribution on the axis, the strength of electric field at a distance x, if radius of the ring is r, lambda is the line density of charge, net charge q equal to 2 pi r into lambda. This you know. At the point P on the axis, we will find strength of electric field, and we got the expression like this: Qx by okay, this we have done. And by putting x equal to 0 at the center, EFS is what? 0. You are supposed to draw the graph of this, but none of you have tried. So I have to do. But that will do in the next session, in the beginning. Graph going to play a very important role for the next session. EFS due to some interesting charge distribution we are doing. This I reminded you. Now, if the ring is divided into two parts, then what will be strength of electric field at the center? At the center, what is the value here? E center equal to 0 because x equal to 0. Now, due to semicircular ring, you just don't divide, you will be wrong then. You say that I will divide in two parts. No. Half of this thing, no. Why? It is because the electric field is a vector quantity. Isn't it? So I am showing you due to semicircular ring, but I can, okay, let us do it for semicircular ring first. This one is a semicircular ring. EFS at the center of a semicircular ring. This is the center. We have to find strength of electric field there. We will generalize the case. It may be semicircular, maybe quadrant of circle. Okay, generalization we will do. That at the end of this session I will give you as homework. But this time let us do it for semicircular ring and for quadrant of circle. This one has radius r and line density of charge is there, that is lambda. Q equal to 2 pi r into lambda. Lambda is the line density of charge. To find strength of electric field at the center. Concept already I have explained what to do. We will divide into infinite number of parts. Due to an elemental portion, which is the representative of all parts, we find electric field at C. And then for the whole semicircular ring, we will find electric. Okay. So imagine that this is divided into infinite number of parts. This ring is divided into infinite number of parts. The elemental part for this be somewhere like this. This is the elemental portion holding a charge dq over there. Due to this dq charge, the strength of electric field at the center will be directed this manner. Agree or not? But if you don't consider the angular position of it, then you will be wrong. This may be elemental portion, but it has some angular position like this. Okay? So what is that angular position? You draw a vertical diameter like this. Imagine that the angular position, this elemental portion we are taking AB. Angular position of this is theta. And this one, this theta. Electric field strength at C is D. This D is how much? AB is the elemental portion. AB is the elementary portion. What is the charge on it? Charge on it dq equal to lambda into what? The arc length AB. But AB is how much? R into d theta. You remember that Figo relation? Arc length is equal to r theta. Here it will be r into d theta because this angle we have taken d theta. So dq value will be how much? Lambda into r d theta. Now what is the electric field at C for that? EFS at C due to AB is dq by 4 pi 0 r square. dq value is what? These two are getting cancelled. So lambda by 4 pi 0 r d theta. Okay? But this you cannot integrate. Why? Because theta is a variable quantity over there. So what I have to do there? I'll resolve this one into components. Okay? What are the components here? This one is theta. So this angle is also theta. Take once. This is theta. So vertically opposite means this one theta, this is 90 minus theta. So dx is there horizontal. And this one d cos theta. So dx, the horizontal component, d sin theta, dy, the vertical component, d cos theta. Okay? So field along x-axis is the contribution of all these components. So how will I find component along x-axis? Net field along x-axis, Ex, d sin theta. Okay? Put the value d over there. Lambda by 4 pi 0 r. What will be the limit of integration? Theta is changing from where to where? This position 0, it will be 0 to pi. Isn't it? Take once. 0 to pi or pi to 0, you decide. Wait, let me complete first. And okay, let us finish it. Limit of integration I have given. Let us complete net field along x-axis. What is integration of sin theta? So there it will be lambda by 4 pi 0 r 1 plus 1. This will be lambda by 2 pi is 0 r. I think you have understood. Huh? Let us find dy now. Resolving along y-axis. Dy is dE cos theta. That is, the value put 4 pi 0 r cos theta into d theta. Okay? So ui will be integration of this is from where to where? Again from, see, I have to cover the whole ring, whole semicircular ring. So the radius vector has to be rotated from this position to this position. Initially it is 0, then 0 to pi. Same. Now do it. Lambda by 4 pi 0 r sin theta 0 to pi. Sin pi is 0, cos pi also 0, so answer is 0. Isn't it? So the value of Ey equal to 0. So electric field is due to which component? X component, horizontally. So if there is a charged ring here, then EFS will be directed this way. If it is lambda, then electric and radius r, then electric field at C will be lambda by 2 pi. Next time I am going to show you with quadrant of circle, charged, and dramatically the expression going to be changed. Let's see what happens over there. This expression, division, divide by 2, it will not help. Why? Because of that direction only. Just draw the semicircle and do before I do it here. Same concept. Only that angle will be from 0 to what? 0 to pi by 2. Yes. So, next calculation going to be EFS due to a charged quadrant of a circle. Today my aim is to show you that do not assume anything here, that this one like this, so it will be like that. No, there is no link. We'll take a quadrant of circle here. Quadrant. Quadrant means 1/4. Yeah. This one is charged. Charged. Quadrant. Due to this, at the point C, we have to find electric field. Okay? This I can do a bit faster because I hope you have understood the method. What is the procedure? The procedure is we have to divide again to infinite number of parts. Isn't it? Again, this is elemental portion. This one elemental portion. It has some angular position, theta. This end had some angular position with respect to the previous one. This is d theta. Okay? So, electric field at C due to AB will find first. This elemental portion. AB length will be same thing, no? Which you have calculated before. AB is what? L trigonometric class 11 r d theta. S equal to r theta. Huh? So electric field will be what? dq you write. So lambda into r d theta. So d will be what? dq by 4 pi 0 r square. Okay? The value of dq is what? By so r are getting cancelled. Okay? Here, now this d will dissolve into components again. Why? Integration of this gives nothing. Wrong. For that particular angular position, this is the direction of electric field. For the whole thing, if you want to do, then you go by component method. Integration of this you can do by using higher integration. That I am not discuss here. Okay. So we go by normal. All the methods are normal. Normal method, if this is theta, this one theta, component this way will be what? Dx. This way it will be dy. What is dx? dA cos theta. Isn't it? And dy also write simultaneously will be d sin theta. Okay? So Ax will be what? And Uy will be what? Isn't it? Okay? Understood? And what should be the limit of integration? I have to cover the whole quadrant. 0 to pi by 2. Here 0 to pi by 2. Okay? So this is sin theta so the value is cos pi by 2 is what? 0 minus minus it will be plus. And here sin pi by 2 1. See the fun? Here both r is there. Both Ex and Uy exist. You cannot assume anything. Lambda by 4 pi is 0. This is also lambda by 4 pi is 0. Isn't it? So what will be resultant field over there? There's both. This is Ex. This is Uy. So resultant will be ER. ER will be what? The resultant of these two. They are equal. So root over Ex square plus Uy square. So lambda by 4 pi E0 R root 2. Hope you have understood. No problem. Okay. See you in next class.